This week's episode of the Uptime Wind Energy Podcast is pretty exciting because Joel, Rosemary, and I take a deep look into the Siemens Gamesa issues. Obviously, they're going through a little bit of turmoil at the moment, and we have a discussion about what that means for engineering and for the company in a larger context. The discussion is not necessarily focused on Siemens Gamesa. I think we really get into a lot of just good discussion back and forth, and maybe a little bit heated at times about how engineering should function. And wind turbine companies have had some real significant design issues and some manufacturing issues to go along with it. Those are really tough to overcome. But Rosemary, Joel, and I have worked at a lot of different companies, and we've seen a lot of different engineering management styles and organizations. And we think sometimes those have a big influence on the quality of the product that goes out the door. So this discussion is really interesting and good, and it's meant to kick off a lot of discussion in the industry of how to run an engineering organization, how to create a quality product, and to avoid some of the costly decisions that Siemens Gamesa is going through. So it's a good episode, so stick with us. I'm Alan Hall, president of Weatherguard Lightning Tech, and I'm here with the vice president of North American sales for Wind Power Lab, Joel Saxum, and international renewables expert, Rosemary Barnes. And this is the Uptime Wind Energy Podcast. So the big news this week, if you haven't seen it already, is that Siemens Gamesa had an internal review to look at the status of their existing onshore and offshore fleet. And during that review, it was identified about $1 billion in offset, which means that they're going to have to set aside about $1 billion to take care of some of the, I think, design issues, is what I'm hearing, and some manufacturing issues. And these are just coming to light after having about a $500 million write-down in early this year, like January. The same sort of thing had happened, preparing for warranty claims and repairs. They're going to have to happen in the near future. This, of course, set Siemens stock tumbling about 25-30%. By the time you hear this podcast, it may have recovered some, because I do think there's value in Siemens and Siemens Gamesa. But it does set everybody in the wind energy space to become really concerned, because you don't want to hear that a large player such as a Siemens Gamesa is having the stock drop and Siemens stock drop. That kind of drop is dramatic and can really injure a company, not in the short term, but really in the long term. And Joel, I know the other players, the Vestises, the GEs, the Suslons of the world, didn't seem to get too rocked by that. It seemed to be almost solely sort of a Siemens event.
Yeah, and I mean, when a company comes out, no matter what space they're in, and they have to basically retract their guidance for the next year, that's a shockwave, right? That's nuclear. It doesn't matter if you're in healthcare or you're whoever. It's going to be a big issue. If you look at the stock ticker, so June 21st is when this report came out. They were trading at $25 a share US. The next day they were down to 16. Since then it's the 28th now, so a week later they've recovered to 17. So 35% down in the last few days. That's brutal.
Well, when it comes to investor advice, right? So they give quarterly reports and they have prospectuses, and everybody makes their decision investment-wise. And you're talking about global investment in a company like that. All the advisors are reading those portfolios and looking at what's going on in the marketplace and trying to predict the future. Obviously, they didn't predict that, right? Because the stock price wouldn't have dropped like that, because usually the market's about 6 months out in front of current status, right? And so that's the trouble. So the market's saying 6 months out, Siemens is going to be really crushed.
Yeah, like you said, it didn't really affect anybody else in the market stock too much. And a lot of times when something falls like that, you will see, like when back during COVID, there was a chip chip company, I don't remember which one it was, that they made an announcement similar to this, and across the board, all of this people that were in that same semiconductor manufacturing, all of their stocks started to drop. So this one was specific to Siemens, it was warranty issues. But we also know through watching this, like they all have it, right? Vestas has issues. Vestas had the same thing happen to them about 2 years ago when they had to sink a bunch of money into. And to be honest with you, like we said, we were actually talked about this, I think last week. I or 2 weeks ago when we were talking about the TPI investment stock, you and I, Alan. And when people were saying like, "Oh, it's a little bit, it's positive to invest in TPI right now because their future looks like it's kind of bright." I follow these markets, and I have for a long time. And to be honest with you, the manufacturers' stocks haven't been doing good for a while. But to see this is a pretty big blow.
Rosemary, I think part of this got triggered because Siemens is requiring all of Siemens Gamesa, that somebody in management thought it'd be wise to do a technical review, basically a critical design review of the existing turbines, what's going out the door right now, and see where they're at. And my guess that would involve talking to customers, looking at warranty claims, talking to repair people about what's happening in the field. And that triggered a couple of alarms. Now, early indications are from a number of various sources that it's blade related on onshore for the 5X, maybe a little bit on the 4X, but also they're having bearing issues related to blade issues in a sense. Not a lot of specifics because they have so many bearing suppliers. There's 4 or 5 different bearing suppliers, and nobody was talking about which one it was. Was it a manufacturing issue with a specific one? That was an early indication, but it seems to be a little bit wider than that. And Rosemary, having worked for a large blade manufacturer, isn't some of these design reviews part of sort of built into the system that normally you would be having sort of critical design reviews of an existing product, or obviously of a new one, but of an existing product to make sure that you are tracking the way you think the design should be going?
Yeah, definitely. And I mean, I'm sure that they were doing design reviews. I don't think that, 5 years ago they stopped doing design reviews and now they realize that's a bad idea. I mean, they were doing design reviews and there must have been some process or some new material or some new design feature that has somehow made it through, the end of its project lifetime to now have rolled out to, all the blades or a lot of the blades. They're saying 15 to 30% affected. I don't know if they're expecting 15 to 30% failures or there's 15 to 30% that have the feature that may fail or one of the features that may fail. But it sounds much less contained than most of the issues that I deal with. So maybe it's a good idea to explain how the development cycle works for a technology project. So, let's say that this is related to something like a new sandwich core material or a new resin or, a new material of some other kind, a new manufacturing process, whatever it is. They'll start out, they'll do, some tests in the lab and some component tests. And assuming that all goes well, then they will implement it into a single new blade. They will make a test blade of that blade. You have to do that for certification. Test that and then roll it out. And along the way, there are different reviews, often called stage gate reviews. So there might be 5 gates. The first one is we've done a business case and this looks like it's a smart project to do. Second, we've, done all of the desktop engineering that you could do to make sure that this is likely to succeed. Third, we've done tests in the lab and it's all looking positive. We've talked with the factories and they think that we can incorporate in there. Fourth, we've made some blades and everything went fine and, the test blade is good. And then at the end of the process, however they line up those numbers and the milestones, at the end of the process, it will have been in several factories and maybe in several blade designs as well. And everything's fine. And they're like, okay, great. This is a new technology that we can roll out at will across new designs. And it sounds to me with such a large affected population, it's not just a few blades from, a new product that they knew was was new, was untested. It sounds like it's made it all the way to the end, and they've been rolling it out en masse before they realized there was something wrong. The fact that they thought to do a comprehensive design review and then were okay to publicly say the results is huge, so it would have started out the occasional failure here or there. And this is the kind of thing that I get involved in a lot when I'm helping clients with like root cause analysis or defects, because at first you have one or two defects and the manufacturer is like, oh, that's a freak occurrence, and then the asset owner is like, oh, seems like we've got 5% of our population affected, and then a couple of months later it's like, oh, now we're up to 10%. Like, this doesn't really seem like that many freak occurrences is something that would have happened. And then eventually the manufacturer is like, okay, yeah, there's some serial issue going on here. We need to go back and like really get the smartest, best engineers on the case, do some tests, like really go through with a fine tooth comb everything that's happened in the all the factories where this issue is coming out of, and figure out what's going on. And so they must have gone through that process to now realize, oh no, this is something that is, there's a feature that turns out to be wrong that's in so many blades. So there's, that sinking feeling of, okay, this is a large affected population. And then there's the next part of that where it's like, well, what's it going to take to rectify this? Because, you need to know what's the effect of this failure going to be. And, if it's a big impact, you could see in some kinds of defects, you might see blades just falling off the turbine every now and then. That's kind of, like the maximum, most catastrophic impact that there could be. And in that case, you need to be pretty cautious about making sure that you get to every blade before that happens. And I don't know if it's that bad for them. It might not be, based on how much money they're saying. They're not going to be preemptively shutting down every turbine and replacing every blade, but it's somewhere along the line in severity where they know that they're going to have to get service personnel out to 15-30%, and these numbers never go down, they always go up on these kind of campaigns, as you realize the extent of it is worse than you thought.
Let's do some backwards math on that. So it says 15 to 30% of 132 gigawatts. So if we say 132 gigawatts, right, times 132,000 megawatts, and if we say these are 5 megawatt machines times 30% of them, that's 8,000 machines that need to be looked at.
And times by 3 to get the number of blades.
Yeah, so that's 8,000 site visits, right? And again, that's armchair math. So you can't really say. But the problem here, one of the problems in the market, right, or as Wall Street and investors are looking at it is if you read through all the in between the lines and in Reuters and everybody else that's talking about this, Electric and all the different places, they're saying one of the troublesome things is they're saying it may cost around this, but they can't actually put their finger on it because it's such a big problem. They don't know. And that's the troubling thing for investors, is saying like, yeah, you're looking at a possible $1 billion, but it could be more, right? Because they don't know.
And an article I read said that they expect it's going to wipe out their profit on all of their service agreements potentially. And I mean, I don't know Siemens Gamesa's specific business model, but in general, a lot of manufacturers are selling their turbines at a loss in the expectation that they make their profit on the service agreement. So they are potentially saying that, everything they've done in the last 5 or so years is going to have cost them money rather than made them money, and it could get bigger. So, I mean, it's a huge issue.
Hey, Uptime listeners. We know how difficult it is to keep track of the wind industry. That's why we read PES Wind magazine. PES Wind doesn't summarize the news. It digs into the tough issues, and PES Wind is written by the experts, so you can get the in-depth info you need. Check out the wind industry's leading trade publication, PES Wind at peswind.com. I think this sounds like an engineering escape, right? And that's what I read between the lines, that there is an engineering oversight that for some effect they weren't planning on happening. It's like a secondary harmonic or some weird vibration that's being induced into the blades that's causing a problem. Or it may be something really as fundamental like a core splice, right? You got something that maybe you changed the material and it didn't perform as you expected. Variety of different reasons, hot, cold, who cares? But I think the design of the engineering system internally is really key to catching those early, right? Everybody has a slightly different engineering group and way of managing engineers. Are they testing themselves hard enough, right? I think that's engineers are not a bunch of people to take criticism lightly, but it's almost like you have to build in a system of criticism internally to vet out these weird problem areas.
Yeah, and I mean that's something that I did see a few times in my career because when I went into the wind industry, I had been outside of it. I'm not European. I worked in a lot of other kinds of technologies before I for about 10 years before I went into wind, and so I would often see risks that people in the industry are like, oh no, that will never happen. Trust us. We've been working on it a long time. That did happen, but never on something this major. So I mean, there is a system in place where you have design reviews and you do something that my company would call it DFMEA, the Design Failure Modes Effects Analysis, where you go through every single design feature, every single way that you can think of that it could fail. And you get a bunch of engineers involved that have, a lot of experience and have seen a lot of failures and can think of a lot of things that can go wrong. And, you spend hours on new designs going through all that. And then you prioritize them. So you assign weightings to how bad would it be if this failure happened. And so, the worst kind of failure is something that might make a blade fall off or might make a turbine catch on fire or could kill someone in some other way. And then you think, how likely is it that this would happen? And then you multiply those two numbers together and something that is, very likely and very bad, then you spend a lot of resources trying to test that to, the maximum extent and be really sure that it's not going to happen and come up with, multiple levels of safety on something like that so that you would need, like several kind of unexpected failures before you would get that outcome. But you can only, it's human based. It relies on people thinking of what could go wrong. And so when you get like a truly new failure mode, it's highly likely that nobody has seen it before. Wind energy companies are pretty good at sharing workers amongst them. I had heaps of colleagues who had spent 3 years at Vestas, then 3 years at Siemens, then 3 years at GE, and might go all the way like through all of them, or at least through all the Danish ones. But they're not as good, in my opinion. They're not as good at getting people from outside the industry. So I guarantee that this failure mode it's not the first time in the whole world of all engineering that a failure like this has been seen. But I would be pretty willing to bet that it is the first time it's been seen in the wind industry, because otherwise I feel like it would have been caught. It would have been, noted as something that was likely to happen, and it would have been tested for, and it wouldn't have happened.
Yeah, but history indicates that most of the failures that happen in sort of larger engineering projects had plenty of warning that were ignored by engineers or ignored by mechanics at the time, or particularly management wants to ignore it because it's not on the high priority list, and it just gets not enough oversight for it. You can name thousands of those.
I think it's really easy to say, oh, there were all the warnings and this was ignored. But the fact is that, you come up with a very, very long list of things that could fail on any project you do. And any project that you do, if you were to test to the maximum every single risk on your list, you would never have an economic project. So you absolutely have to prioritize And, like if just because this risk was on the list kind of towards the bottom with a low expected likelihood of failing that way and a low consequence, that's different to being ignored. If it was high risk and high likelihood, then the system should be set up that you can't ignore it. You can't pass, the gate that you need to move to the next project phase. And I mean, if that was the case, that had happened, then management would be getting fired.
Well, that's what's happening now.
Now they're saying, like, basically they're coming out and saying after the merger, they're realizing some stuff and say, oh, wait, too much has been swept under the rug here. Right. And that's the words right from the press script. Too much has been swept under the carpet. So there's actually like a cultural problem, it sounds like, from some of these reports at Siemens Gamesa. So in the ideal world, Rosemary, like you're saying, absolutely, all these engineering concepts, processes, and things would be in play. But if there's somewhere along the line, someone sweeping under a rug, or they're not paying attention to it, or they're doing something to disguise this, which I'm not saying they are, but the reports from it say too much has been swept under the rug. We've got a cultural problem. I'm going to expect that there's going to be some director level heads rolling from this myself after an internal investigation.
I mean, it could be pushing things through to the next level when it wasn't ready for it, and which does happen from time to time. If you've got an order of 1,000 turbines and you have one or two things to check off before you're actually supposed to go through to serial manufacturing, then yeah, certainly sometimes that gets pushed through. But then the really common one that I see like that is where people won't accept that it's a serial defect until way past when it's obvious. I see this time and time again when I'm getting involved in root cause analysis. I'm like, your root cause analysis shows that it was, a freak one-off, and it is just not plausible that this same thing has happened, on 5 or 10% of the blades of this wind farm, and you're just saying that we're unlucky. Like the statistics just say, no, that's not possible. Yeah, but it can take a year or, longer before management at the manufacturers don't seem to accept a serial defect until there is literally no other explanation, and any idiot could see it. I guess is a strong incentive to hope at least that defects are one-off fluke occurrences.
Joel, I mean, we just went through this a couple of years ago with this lightning issue with a single manufacturer, right? How long did they push off denying this is a solo event, doesn't happen anywhere else? Meanwhile, you're hearing about it in other countries, same thing.
They're still trying to push it off.
That's a cultural thing.
If this was a merger that was company XYZ and company ABC, you're going to be looking at that. But when it's essentially Siemens eating themselves and then finding the issue, right? They made their own dinner and now they're getting food poisoning from it, and they're like, "Oh, well, this sucks." That's what's happening. So the parent company took a dive too. Their stock, and not as extreme, right? They went from like $84 or $87, like 83. They lost 5% in value or something.
All one party now.
Yeah, somewhere along the line, there will be some systematic changes within how they either culturally, people at the director level, how they do what we're talking about here, engineering review, these kind of things. Because I mean, we have seen serial defects, and this is what this screams serial defect, right? When they're like 15 to 30%. So that's a design issue in my mind, right? And Rosemary, correct me if I'm wrong, but I would say 15 to 30% of the fleet, you got a design issue, you got a big problem. You've got to go check this out. So there's something there that got through. $1 billion is hard to swallow. And I would say that will take profit from all their services or service work from more than even just this year.
Not to mention sales going forward. I mean, if I was advising someone of which turbine they should be buying for their upcoming project, then, if they were considering Siemens Gamesa, then there's a few key bits of information that are missing that I would need to know before I felt comfortable recommending any of their turbines going forward. I would want to know, one, what the problems were. It's probably several. And what they're doing to fix it, how they missed the old thing, and how they're going to be sure that the design fix has been tested better than the old one was. And I mean, it took years for for this previous problem to be discovered, I'm not going to be convinced with, some desktop engineering that, okay, the new fix is all fine. I'm going to be wanting to see test results and operational results from a statistically significant number of blades or turbines, depending on what the issue is. So that means, tens of turbines, not just, one test blade and that's fine.
Yeah, and we're good.
Yeah, exactly. So, I mean, that's years before people are really going to start feeling comfortable about this product again.
Yeah, and didn't we just see an article not too long ago that said like Siemens order book is starting to surge a bit? Like, so they're just starting to come up. Oh, brutal.
How would you feel if you had just signed on the dotted line for a wind farm full of Siemens Gamesa turbines? You'd be trying to back out of that as...
You would.
Yeah, I mean, you would. The only thing that might save them is that it's impossible to get turbines fast at the moment. So, if you're about to have some Siemens Gamesa turbines delivered, then you may well be convinced okay, yeah, well, this is what's coming and this is what we understand and this is what we're going to do about the blades that are and other turbine components that are already installed. But my goodness, this is not going to be good.
I would classify it as a force majeure event. If I had just signed for a wind farm, I would try to go with that, because there's always that backdoor clause in every contract, especially when you're talking big industrial cash like this in capital. If you're, I would say, because so Rosemary, you're in the blade world. I'm in the blade world. Alan, you play in the blade world as well. I'm gonna say right now, I believe I know which one of the models of this thing for sure. I'm not going to say it on air because I don't want to be wrong and I don't want to say something into cast. But that's a barroom whisper. Everybody knows what model one of these is. And if you had just ordered some of these, you're definitely backing out of this. I would like to see. So in a couple of these articles and because of what we know, Q3 coming up, August 7th, they're due to do a report. A filing for Q3. So I'm going to tell you right now, I would say that's not going to come on August 7th. They're going to file for an extension. It'll be mid-August, end of August before anything comes out. And when that report comes out, you're going to see some answers. Hopefully, us as an entire industry will hopefully get some answers out of it. Financially, yes, and then hopefully, within those, there's qualitative data and quantitative data. So we'll see some numbers, we'll see some changes, but hopefully they'll outline what the issue is, what model it is.
Models.
It has to be, yeah.
Does that mean, Rosemary, that from an engineering standpoint, let's just sort of break this problem down a little bit. I think they have an engineering issue. They have clearly a management disclosure issue internally. And then they have a third, a customer issue they got to go figure out. On the engineering side, what happens, Rosemary?
Well, I think it's really easy in these cases to say, oh, they've got a management issue. And in a way they do. However, everybody has that same management issue, which is the tension between sales and engineering. And, the engineering never gets done to the extent that the engineers want it done. And it's always done more than what the sales team might like to see, So if someone was deliberately hiding or deliberately ignoring known problems, then heads definitely deserve to roll. But I feel like we would have heard more about that aspect of the story if that's what it was. I suspect that it's more like just the regular everyday mismanagement of saying, yes, we know that these issues are a risk, but it's worth the risk for the sales. If we were to halt everything to address all these risks adequately, then we would miss out on these sales and the company would, cease to continue without sales. That is like a routine everyday management dilemma and, a fight that every engineering company I've ever worked in my whole, nearly 20 years now of career, that's an argument that gets had on every single project between engineers and management. So that's, engineers would say that's mismanagement and they're right. But on the other hand, managers think that engineers are just so naive that, in terms of the business world.
Wind turbine blade damage occurs every day all around the world, and finding knowledgeable engineers to get your blades back in service is a serious problem. And as we know, operating with damaged blades is really, really risky. Well, there is a solution Meet Wind Power Lab, your ultimate partner for blade risk management. Wind Power Lab's team specializes in all things blades, from in-factory inspections and root cause analyses to aftermarket product guidance and end-of-warranty campaigns. It's time to get those damaged blades back working for you. Connect with the global blade experts at Wind Power Lab by visiting windpowerlab.com.
I want to know, what do you guys think about other companies? Because like I mentioned, in the wind industry, and especially in these, wind manufacturers in Denmark, they churn through their staff. They get spread around. Everybody has worked at, a lot of people have worked at a lot of different companies. So if this issue happened here, and I think it must have legitimately surprised some people. Are we going to see this surprise or something similar in other companies as well? Or is it going to be a feature? I mean, are there really that many features that are so unique to Siemens Gamesa that it couldn't possibly spread to someone else?
I think that this could raise hair and raise tensions a little bit more along the article that we saw, like Vestas came out with the other week, that was like slow down to increase speed, right? So the OEMs have been, we've been talking about it for the last year and a half on this podcast about we're basically building prototypes in the field as production units. And it's because of the demand of the market, right? They want the next best thing, biggest, baddest, blah, blah, blah. But that has created this snowballing effect of issues where all of a sudden the OEMs are, calling $1 billion loss here. We had Vestas I think it was $700 million for Vestas 2 years ago. Like when these things start to snowball and get worse and worse and worse, if it continues that way, then we're going to end up with no OEMs to build these things, and that's not where we want to be either, right?
I remember when we had that conversation about Vestas, and I was criticizing them, saying how you can't just halt technology development or you'll lose sales. I guess that's the good management in the sense that engineers would see it. So maybe they are coming down on the side of, maybe Vestas will be the last turbine standing now, because they're the only ones whose management are prepared to say, these issues are big enough that we need to stop and pause and take care of them before we move forward.
I would be willing to bet you that if we dug through some data and figured out, okay, hey, say since year 2010, how many new models of turbines were introduced from each of the major manufacturers, we'll see this increase. And I would be almost willing to bet you that this event, when we look back 2, 3, 4 years, when we're in the future to now, will flatten that off. Because I can see people, the whole industry, and one of the other things I'm thinking about here is at what level of disruption to the market does a government step in, right? Does FERC or because then you start talking about energy security and things like that, right? Are some of these guys going to have to go sit in front of the EU chancellor and explain themselves when the EU is trying to move forward with a lot of, like Green New Deal type things like we are? Or I know, like, if this was a US manufacturer this happened, they may have to go sit in front of Congress and explain themselves, because then you're talking facts of energy security, and that's, I'm using that as a buzzword, but it's a problem.
GE has already cut down the number of turbines, right? So months ago they were on this plan to reduce the number of models, towers, everything, the cells, everything. They're just going to slash that down. I mean, what Vestas was saying, GE was implementing, Siemens was headed that way anyway, right? The question is, Siemens got caught up in an engineering snafu that they're trying to unwind. I do think they have to, having gone through these situations and seen it on the aerospace side several times, they're going to have to try to provide a different sort of structure, right? I think organizationally, management-wise, they're going to have to provide a different structure. Otherwise, the market won't buy into it. They have to show, Joel, you're absolutely right. When they get to August and they start having quarterly report again, they have to come with some sort of adjustment saying this is why going forward, this is not going to happen again. If they don't do it in August, they sure as heck have to do it by the end of the year to show that there's been a change. And Rosemary, I think you're right also in terms of the way that the engineering is constructed and people hopping from sort of place to place to place. But Joel, what's the first rule of Fight Club?
Don't talk about Fight Club.
But that doesn't mean there's not a Fight Club, right? So we talk about engineering like there's no combative situations happening in the inside the engineering areas. There 100% are, and they have to, right? And those combative episodes happen mostly between engineers and management. Those things need to happen. If they stopped happening because the engineers went passive, which is what they tend to do, they go passive aggressive and say, fine, all right, sure. If you want to put that wind turbine out, sure. We'll sit here and drink coffee and do our thing. And I think Rosemary's seen it. I've seen it in the engineering world. You can't give up on the Fight Club. The Fight Club still has to exist, or you got to get the hell out, right? I think engineering wise, you need to do that.
When there's things that, at some point engineers do feel ethically torn over something. If they've raised concerns and it's not being taken seriously, then engineers will start quitting. And, I've seen engineers quit over their concerns not being taken seriously. I haven't, maybe you guys can tell me if you have, but I haven't anecdotally heard of heaps of people quitting Siemens Gamesa compared to normal. You have, Alan?
Yeah, I have.
Yeah, I mean, I think that would be an indicator of a real cultural problem more than just the normal tensions. And I was describing before.
Right. I'm not saying there's anything. My indications are not systemic, right? It seems to be one off here, one off there. But again, it's back to like the serial defect thing. It's always a one off. It's always a one off until there's dozens that are walking out the door with concerns. And I'm not sure Siemens Gamesa is different than other OEMs. Just like in the aerospace side, you hear people walking out of Boeing and Airbus all the time for disputes that they have engineering wise. That I think is fine. But I think you have to build in a Fight Club into your engineering organization, right? You have to have to suss out what's real, what's not, get to a higher level. And the only way to do that is to sort of internally challenge yourself. That doesn't go over well in a lot of engineering organizations. It's a tough working environment because you always feel like you're being attacked at some level or being criticized, but only what it comes about at the end of the day, and maybe Rosemary's experience is different than mine, is that we seem to have a little bit of better product and maybe build a little weirdly camaraderie. You have to be willing to challenge what's in front of you to make a better product.
So here's a question for you, Alan, then, and Rosemary as well. Siemens Gamesa is a German-Spanish company. Two very, very, very different cultures. Do you believe that some of this could still be stemming from the Gamesa mergers and stuff from years past in the engineering side?
I don't know. You got to throw Danish in there too. The blade design. It's one of the Danish companies, even without that being in its heritage. I don't know to what extent they ever really properly meshed. Certainly, the impression that I got from working with them was it was Danes and a few Germans, I guess, for onshore and Spanish for offshore. And I don't think that they ever really got the one culture across everything. I mean, certainly they would have had processes standardized across factories and stuff, but I would be surprised if that was the cause of the issue.
I'm with Rosemary on that. I don't think that is a driver as much as if you're tasked with running that organization and you have two separate companies, two separate cultures, it is your job to fix that and to make it one company.
Change management is not easy.
It's not easy, but that's why you get paid the big bucks, right? It's Fight Club, guys.
Like you said, it's a really hard thing to try and get on with your colleagues, but also to fight with them. And I mean, I certainly had plenty of fights in design reviews, and you need to see more of that.
Yes, I agree with you, Rosemary. You should.
But it's career limiting to be that person. I'll tell you that now.
Yeah. Hey, I've been there before too. But here's let me give you not a tale of caution, but a case study. MHI Vestas. What happened there? Vestas, Danish company. MHI comes in. MHI is Mitsubishi Heavy Industries. It's a Japanese company. They came in. They said, we're going to take over the offshore world by storm. It lasted, 2-3 years? Culturally couldn't work. Back out. Now it's Vestas again. Right? So same kind of thing with two very different cultures. They saw the issue and said, this isn't going to happen. Let's split it back up.
No, but like trickling of changes, individual hires from different people, recognizing that people from other industries have something to bring. And I'll be honest, I think that Europe in general is bad at this. They tend to see like really linear career paths, and they want you, if you're going to apply for a new role, you better have done that exact role before. Otherwise, they don't think that, you can, you've got anything to bring. I see that with the automotive industry in Europe as well. And, try and get a job outside your industry in Europe, and it is incredibly challenging because I don't think that they really respect diversity of the right kind. Like diversity doesn't just mean that everybody doesn't physically look the same when you're in a meeting room. Diversity means people have different experiences, so they're going to see different potential problems and think of different potential solutions as well. So I think that, like individual hire by individual hire is the best way to do this, but that's not fast,
If you're letting human resources decide who your engineering team is, you are screwed. I think that is what's happening in some of these places where, again, yeah, you want to try to pick people from different industries, you want to have different experiences, you want to put them together and lock them in a room and let them battle it out. I think, but sometimes what's happening is we're having, at big companies, HR makes a lot of decisions, right? And maybe they don't have the right mix.
No, but I think that the management needs to believe it. That's the problem. Like HR kind of diversity is much more of the like box ticking kind, but this is a level deeper than that. It's where the management would need to not pick people who are just like them and telling them how great their decisions are, which is, the really comfortable, nice way to do things. And that's the way, if you want to, progress through your career quickly, you find a manager and, become just like them. And people tend to promote people that, remind them of themselves. That's an excellent way to end up with huge company-wide quality problems. Yeah, if you just do that. So instead, you've got to say, okay, I'm a manager and I'm going to end up with a better, stronger company if I am a bit uncomfortable and I recognize that, different experiences that I don't have are going to be valuable. You will sometimes make mistakes, That's not the safe thing to do. You're not as well equipped to assess how good that person is. But overall, over time, I mean, if you look into the data on diversity, it does improve things when you have that real kind of diversity of thought.
So we'll see if that happens within Siemens Gamesa, right? There's going to be a deep investigation into this because nobody has $1 billion possible loss and doesn't dive in, right? And of course, we're probably not going to hear all the results. Nobody's going to publish a report that says, here's where we messed up. But something will come out of it. We'll get more news on this as it develops.
We should take the time to plug at least Paddler Consulting and Wind Power Lab. But if you have a fleet of these blades and you're feeling worried, then you're going to need somebody who knows the industry to get in there and have those conversations to make sure that things are taken care of. And
get a lawyer before you sign anything. Yeah, for retrofits, repairs, whatever they're going to say they're going to do to these turbines, have a third party, someone independent review that contract before you sign it. No matter how much you like your salesperson or how many dinners they've taken you out to. This is it's not a small issue here.
That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please give us a 5-star rating on your podcast platform and subscribe in the show notes below to Uptime Tech News, our weekly newsletter. And check out Rosemary's YouTube channel, Engineering with Rosie. We'll see you here next week on the Uptime Wind Energy Podcast.